So what I'm going to be talking about is why positive security is the next security game changer. Before I do that, let me tell you about today's challenges that I see with software security that we have at the moment. We have about 22 million developers out there in the world writing code. They're writing about 111 billion lines of code, right? And that's not surprising because everything these days is powered by software. And this is an interesting one for us, right? For every 50,000 lines of code, we're introducing 1 to 4 security bugs. So what that translates into is we're potentially writing in 2 million exploitable bugs every single year. Now, if you look at a report from Department of Homeland Security in the US, they say 90% of the security incidents result from defects in either software design or software code. Verizon does this data breach report every year. In 2018, they found that 21% of the software breaches were caused by a software vulnerability, right? And it's not just that, it's the fact that for the last 10 years, they've consistently been finding the exact same thing. Cisco does this report called Cybersecurity as a Growth Advantage. And what they found is even more interesting. Even today, every 1 in 3 applications that they scan has SQL injection, right? If you're at an OWASP conference, you know about SQL injection. You know it's one of the most common vulnerabilities. We've known about it for 20 years, and they're still finding it every single day. Now, that's a lot of numbers, right? I've thrown a lot of statistics at you, and you're going to say statistics can prove everything, right? But they can't all be that wrong, right? So there is some truth to that numbers. Now let's go back in history and see how did we actually end up here. So let's look at AppSec, what it was like in the 2000s. Pretty much corporates just had this, brochureware branding website that they were using. They weren't doing too much with the internet. The internet was mainly for geeks, right? AppSec was virtually non-existent in the corporate world. Hacking was mainly focused on perimeter security and networks. No one was really talking about web application. We were just starting to do research on web app weaknesses. Now, interesting fact, this is around the same time when OWASP Top 10 actually came about. It was around 2002, 2003, when we had the first version of the OWASP Top 10. Now, here's the problem with 2000s, right? We had way bigger fish to fry, right? We were dealing with Y2K. No one had time for application security, so no one was worried about it. So let's move forward 10 years now. Where did we end up in 2010? Well, everyone was now buying into this Web 2.0 and mobile craze, right? Companies were starting to offer these services on the web. And penetration testing was the thing. That was your application security strategy. We thought web application firewalls, they will stop everything. You can write as much bad code as you want. As long as you have a web application firewall, you're all good. People were starting to introduce paper-based secure coding guidelines. And static code analysis tools like Fortify and Checkmarks were starting to emerge. And here's the problem that we kind of had for the next 10 years, right? Monthly data breaches, getting more and more severe, hackers everywhere, and then you have all these compliance requirements that you have to try and meet. So things were hard. Let's look at where we are right now today. Everything runs on software, right? Cybersecurity and AppSec are actually really hot topics. They're now starting to cross over to the mainstream media. Static source code analysis tools, they're still here 10 years later. We now have runtime application security protection as well. This is essentially WAF++, right? So you have your code that's running, and again, don't care how bad it is, we will stop things at the perimeter as they're coming in. We also have dynamic application security testing. This is all about running code in a QA environment and then poking holes at it. We also have interactive application security testing. And this is a similar concept, except it's only poking holes as you functionally test the application in a QA environment. And then you have bug bounties. But I thought, hey, you know what? Let's stay with the theme. So I'm going to call it crowdsourced security testing. And bug bounties are pretty much penetration testing, but you know what? Instead of one tester, let's throw 1,000 testers at it. Surely they'll find all the problems. But also, we're starting to see some other interesting trends, right? DevSecOps or SecDevOps, things like containerization, integrating security and ops into your development pipeline so you can move faster. And then also this concept of shifting security left. This is an image I really like. So this is pretty much what your application security strategy looks like in 2019. A whole bunch of star ASD tools. You've got this beautiful soup. So what is a challenge that we have in 2019 now? Well, the first one is right to left is backwards. If you're doing application security right at the end, you're going to have a bad time. So let's take an example here real quick. Let's take a quick detour. We want to provide a service that transports stuff from point A to point B. This is how a civil engineering discipline would do it, right? Looks pretty good. The Harbour Bridge in Sydney looks quite pretty. But then also, one of the key pillars in civil engineering is it has to be secure, right? It has to be able to take the load of cars coming in. You can't just have the bridge cracking under you. And for the most part, it's quite robust. Except they did not account for wallabies. So every now and then you get a wallaby on the Harbour Bridge and shuts everything down. But apart from that, fairly secure. Now, if we look at the software engineering discipline, still transporting stuff from A to B, still functional, but doesn't quite look the same, right? Now, companies, they need to ship features. You need to ship it quickly. So that's what you do, right? You ship it like how it is, and that's what your customers have to deal with. Now, some companies, they're bigger, they have compliance requirements, they have regulation, so they get security experts to do their best to try and make this bridge as good as possible. But here's the problem. If you need to go from that to this, it's almost impossible, right? The only way to do it is you've got to start from scratch. It's 30 times more expensive to fix vulnerabilities at the end of the software cycle compared to in the beginning. What's the next challenge we have with software security? Well, security versus development is a completely unfair game. So we got developers on the left-hand side, and they're not taught security skills. And it's not their fault. You're not taught security skills when you learn development, software engineering at universities, right? So developers without security skills, big problem. On the other side, you've got your security experts. And those traditionally tend to not have coding skills, right? So if you're trying to get these two to work together, you're going to have a very, very small chance of success. Now, if you look at a typical enterprise organization, for about every 100 software developers, they have 1.25 security experts, right? That's all you have to deal with as an application security team. Now, the other problem that you've got is developers and security speak completely different languages. Developers are your builders. They know their code really well, but they do not speak security, right? They talk about languages, frameworks, Java, Spring, Angular IO, React. They talk about APIs, functions. You look on the other side, what are the security guys talking about? Well, they're always pointing out problems, right? So imagine building something, it's your baby, and another guy comes around and says, hey, what you built is absolutely crap, right? That person is not going to be very happy. That's a negative experience for them. Also, they're not developers. So they're talking about SQL injection, insecure direct object reference, but that does not translate over to an API or a function that a developer can understand. So that is a problem. Another challenge that we have is this black hole of security knowledge. Now, you have all your star ASD tools. They're finding security vulnerabilities, or your security experts are doing penetration testing. They find vulnerabilities in the code. The results are lodged into some sort of bug tracking systems that developers have to go and fix the problem. That's a tough thing for a developer to do. They need to research about the vulnerability, understand the concepts, and then translate all that security speak into how do I practically, in my code, fix that vulnerability, right? And that can sometimes take them a really long time. Now, they might get around to fixing that vulnerability and do a really good job, but then the problem that you've got is all that knowledge that they've just gained has gone into a black hole, right? They're not sharing that knowledge with anyone. And as a result, you keep seeing the same bugs reappear. So this is why we're seeing, even today, we've got 125 plus common vulnerabilities, right? Imagine that. Can we possibly imagine every single developer knowing about each of these vulnerabilities intricately and knowing how to not make these mistakes in their code? It's almost impossible, right? And we keep seeing the same vulnerabilities year over year over year because we're not learning from each other. We're not distributing this knowledge that we gain as developers. And as a result, today's apps are ripe with vulnerabilities. And if you're an AppSec, like I was back in the day, that's kind of what that feels like, right? You're just constantly sweeping away, and things just keep coming back. It's just an endless cycle of vulnerabilities. So, what's the solution? Whoops, sorry. Let's empower developers to code securely. How do we do that? Well, let's shift security to the left, right? Let's fix this problem of security coming right at the end. How do we do that? Let's empower developers when they're writing code, or even before they're writing code. Let's teach them about security principles so they're always thinking about security when they're coding. The other thing that we're really bad at as an industry in application security is we're always talking about mistakes. We're always talking about bad things that are happening. We're talking about SQL injection, cross-site scripting, the OWASP top 10. Let's stop talking about that. Let's start giving guidance to developers. Let's start talking about preventative controls that they can put into their applications so they don't actually introduce vulnerabilities in the first place. The other thing that we need to start doing is distributing knowledge, right? So let's take this example here. So you've got one application security expert that comes up with a set of secure coding guidelines that we need to put into an application. Things like we should be doing application logging, or we should be doing context encoding on any sort of user input. Now, what you want to do is translate that into something developers would understand, right? So let's work with developers to create secure coding rules for their particular language and framework. So when we say application logging, what that actually means is for this project, everyone should be using the secure logger library and the log object function. To make sure we're doing context encoding correctly, let's use the get parameter function, right? For a developer, that is a tangible guideline that they can incorporate into their code. Now, what happens on commit? Well, automatically, when a developer builds their code maybe violates a security rule. They find out straight away, and they can go and fix that vulnerability before it even ends up in a penetration test or a static source code analysis result. Now, if they disagree, they think, this code is actually valid and does not lead to a vulnerability, they can fill their get out of jail card. And then also, because we want to make it a positive experience, every time they do the right thing, maybe let's give them some points. The other thing that you can start doing is learning from our mistakes, right? Vulnerabilities are going to happen. We cannot avoid that. So let's say there's a security vulnerability where we say sensitive data was not transported securely, the developer figures out what is the best way for them to fix that vulnerability in their language and framework. In this case, they need to be using a TLS function when they're transporting sensitive data. What you want to do at that point is add that to your secure coding guideline, so next time a developer commits code, you've now built this library of secure coding guideline that the code is scanned against every single time. So over time, you built this really robust library of good things that developers should be doing, so you never have a vulnerability. The other thing you can start doing is make it fun, right? Yes, you have to learn about application security, but it doesn't have to be boring. Why not make it a fun experience? So this is Insurance Australia Group. Actually in Sydney and in Auckland, they have this project called Game of Codes, where they encourage developers to learn about secure coding and application security, and they've created this awesome program where they give out headphones, they have t-shirts, they give away prizes for people doing the right thing. And that really encourages developers to learn about security. We're also doing our part. So this is a platform that we've built where we use gamification to teach developers how to code securely. So you can do something similar. Steven mentioned the Facebook CTF. That's another great tool that you can use just to gamify things and make it fun when you're teaching developers. And then we also get the opportunity every now and then, so anytime I go and do some training, instead of just going and talking to people about application security and doing the PowerPoint of death, we do themes like Star Wars. So I actually have a big collection of Star Wars t-shirts and costumes that I pull out every time we have to go and do some training. So, some key takeaways. Focus on positives instead of negatives, such as security fundamentals. Distribute knowledge to scale AppSec. You cannot do it all by yourself. Define good patterns and reuse them. And just put some fun into everything, right? Who doesn't like a bit of fun? And remember, secure developers are superheroes. And that's my talk. Thank you very much.
All right, do we have some questions? I have a question, or a few. So I watched this talk with my developer hat on, and all that sounds fantastic. It would be excellent if our security team could come in and do all those things. How do you sell this to the executive level to get the budget to do this? Any ideas?
Yeah, so a really good one actually is if you talk about what the cost is of fixing a bug, right? So in every organization, you're going to know what the cost is of fixing a bug. So if you take a rough number like, hey, it cost me $500 to fix a bug, right? And you talk about, okay, well, if it's 30 times more expensive to do it at the end, how much money are we saving if we're fixing that bug in the beginning in terms of the hours spent by a developer, and then also the actual tangible cost that it's going to cost them to fix the bug. And then if you can put that in numbers, you're going to basically get that buy-in from executives.
All right, so you have a business case.
Yeah.
And another one that's great for developing new applications, especially front-end applications. What about the legacy systems?
Yeah, so legacy systems, that's a really good question as well. So one of the things that we often struggle with is people say secure coding guidelines. That's a big project, right? Imagine coming up with secure coding guidelines for an existing application. Instead of coming up with everything on day one, just look at what your top vulnerabilities are, right? Things that you're finding over and over again. Break that down into what that looks in terms of code and start with one or maybe two secure coding guidelines. And what you're going to see is as developers stop making that mistake, you stop seeing those vulnerabilities. And then you can focus on the next vulnerabilities that are coming up, and then you can start writing secure coding guidelines for that. So you don't need to know on day one what all of your secure coding guidelines are. You build that over time.
Awesome. Any more questions from the audience? Awesome. Well, we have about just under, well, we have exactly 15 minutes before we have the final. discussion. When the other room finishes, they will be coming up this way. So as soon as they start filling in and filling seats, we'll get the ball rolling and finish up. Please give a good round of applause for Jaap.